So what we're pretty much doing is we're looking at how animals move through natural environments. The reason why we're interested in this is because traditionally biomechanics has focused mostly on looking at locomotion on very sort of smooth, non-slip surfaces, very simple environments. But the reality is that if you go outside and you look around your natural world, there's nothing simple about it, things. So what we're really interested in looking at is what aspects of the control mechanism allows us to actually move through the environment so just effortlessly day to day. Pretty much what we do is we have them run down a trackway, we have them run up perches, we give them various different challenges. In this case, we've been looking at sort of lizards' reactions to perturbations, so slip perturbation, and looking to see how they actually recover, when they recover, what they're actually doing when they don't recover, what happened that led to them not recovering, to try to get a better understanding for the control mechanisms that actually drive their locomotion. Yeah, so from the human health perspective, there's one of the leading sort of causes of death, of really its mortality and morbidity among the senior population is injuries due to slipping and falling and subsequent loss of health because of that, and then that leads to decrease in health and people eventually dying. And so this is a major, major public health concern. And from that standpoint, what we're really hoping is that we can get a better understanding of what are the mechanisms that are important for allowing animals to recover from different types of perturbations of different levels of complexity. And then we can apply that back towards sort of our senior population and looking to see what can really actually be done to either help with therapies or modifying the environment so that's something that's much more sort of user-friendly, so to speak. And then the other aspect is from the standpoint of robotics. So as we all pretty much know from just looking at robots, we've got some really cool robots out right now, but they have several major challenges, major hurdles that they're still trying to overcome. One is, how do you get them to move quickly? And the second is, how do you actually get them to traverse obstacles, and how to get them to traverse them quickly and effectively, where maybe we can come up with a very simple algorithm that can allow them to deal with a bunch of different situations, so you don't have to code them for every single type of obstacle or problem they're going to run into. And instead we can use one bigger, simpler package that can actually work across a bunch of different situations. I have to always remind myself that I'm actually really, really lucky about being able to see is I get to slow the motion down. And there is so much stuff that we miss on a day-to-day basis because we don't catch it. Or we see the motion and we have no idea how complicated it really actually is. And so we're taking this time and we're just elongating it, and we're looking and seeing all these little details that we otherwise miss. So that's also just one of the best parts too, is getting to actually see things that most other people never actually get to see, even though it's right there in front of us.